Next, frequency distribution. Now, sometimes if the amount of data is large, it becomes repetitive, meaning that some observations will appear several times. If, for example, you walked into the same class and asked the ages of 120 students, you would expect many of them to have the same age. You might find 20 students being 10 years old. So you don't want to write 10 years 20 times. We instead use a frequency distribution like this one. From this frequency distribution, you see there are 12 students who are aged 8 years, 23 students are aged 9, 26 students are aged 10 years, and so on and so on. We can calculate the measures of central tendency for a frequency distribution. But first, we arrange the data into columns. Ages are the observations, so we use X. The number of times an observation occurs is called frequency, and it's represented by F. The summation of frequency gives the total number of students. Mean. The mean for a frequency distribution is given by two methods. One, the direct method, and two, using an assumed mean. Let's start with the direct method. In direct method, mean is equal to summation of fx over the summation of f. From this formula, it means we need another column of fx. That is, we multiply each observation by its corresponding frequency. So these are the observations and their corresponding frequencies. To get fx, we have 8 times 12 will give us 96. 9 times 23 is 207. 10 times 26 is 260. If you do the same for the rest, you'll have 275, 240, 156, and 28. The summation of fx, we shall have 96 plus 207 all the way down, and we get 1262. The summation of frequency is the total number of students, 120. Therefore, mean is equal to 1262 over 120, which gives us 10.5 years. Now we use the assumed mean method. Now, when the number of members in a list is large, the direct method of finding the mean is quite arduous. From the data, we can guess the expected value of the mean. This expected value is called the assumed or working mean, represented by A. The assumed mean is approximately in the middle of the data. In a frequency distribution table, the model value provides the best assumed value. But then, the assumed mean does not have to be one of the values given. After we choose the assumed mean, we find by how much each observation differs from the assumed mean. This difference is called the deviation d. d is equal to x minus a. And then, mean is given by a, the assumed mean, plus summation of fd over summation of frequency. From the formula, it means we need a column for d deviations and then another one for fd. Let's have an assumed mean of 10. We now calculate d. 8 minus 10 is minus 2. 9 minus 10 is minus 1. 10 minus 10 is 0. 11 minus 10 is 1. 12 minus 10 is 2. 13 minus 10 is 3. And 14 minus 10 is 4. Now fd, we multiply the frequency times the corresponding deviation. 12 times minus 2 is minus 24. 23 times minus 1 is 23. 26 times 0 is 0. We proceed the same and we shall get 25, 40, 36 and 8. Summation of FD is 62. Summation of frequency is still 120. Therefore, mean is equal to 10 plus 62 over 120. That is 10 plus 0.5, giving us 10.5 years, the same figure we obtained with the direct method. And so you see, by knowing the formula, you will know which column to create. The mode for a frequency distribution is the observation with the largest frequency. In this case, the model age is 10 years because it has a frequency of 26. Next is median. Now, in order to find the median of an ungrouped frequency distribution, we introduce another column called the cumulative frequency, which is basically the running total frequency. This is how we obtain the cumulative frequencies. We have our observations and their corresponding frequencies. The first cumulative frequency is 12, same as the first frequency. To get the second cumulative frequency, we will add the first cumulative frequency to the second frequency. So we have 12 plus 23, and that gives us 35. To get the third cumulative frequency, we add 35 plus the next frequency, that is 26. That gives us 61. Then we proceed. 61 plus 25 gives us 86. 86 plus 20 is 106. 106 plus 12 is 118. 118 plus 2 is 120. We know the median is the middle value. There are 120 observations. Being that it is an even number, it means there are two values in the middle, that is observation 60 and 61. Reading the cumulative frequency column, the 35th student is aged 9 years. From the 36th to 61st student, they are all aged 10 years. It therefore means that the 60th and 61st student are aged 10 years. So we get the average. 10 plus 10 over 2 is 10 years.